All right, number 4 looks like a monster, and it is. Here it is. And so it should be really obvious, like when you look at this, what the first step is going to be. Whether you look at this, if degree of p is greater than or equal to p of q, then it's improper polynomial division. All right, or you begin looking at a flow chart. Is degree p greater than or equal to degree q? Yes, it is polynomial division. Okay, and then this also tells you on the polynomial terms, we're going to use a power rule, and on the proper remainder, we're going to go right back into our flow chart here. All right, so let's see how that works. So first of all, I have to do the polynomial division. So I have to do x squared. It's going to be time consuming. I'm going to have to watch details throughout and be really careful and clear and complete at every step. 3x cubed plus 25x squared plus 66x plus 25. Right, see, would I leave it like that? No. Why? Because the division sign does not cover all the terms, right? Just for people who need to have that pointed out. So you can adjust things like that as you go along. All right, now I say, how do I divide this into this polynomial? I always start, in polynomial division, you start with leading terms. How many times does x squared go into 3x cubed? That's all you have to look at. Well, it goes in 3x times. I like to put the 3x over here so I keep it in line with my x column, but you can put it over here if you want. Some people do. All right, and then I multiply all this out, and I get 3x cubed plus 24x squared plus 54x, right? I'm just distributing the 3x on each of those terms. Then remember, you're going to subtract, so that switches all these signs. Some people go through and change all the signs. You can do that if you want. I just remember that the minus sign is outside parentheses, so you're really doing this. And then we have plus 12x, and we bring down our plus 25. Then we say, how many times does x squared go into x squared? It goes in 1 time, so I put a plus 1 here. Always looking at just the leading terms. Multiply all these terms by 1. I'm just going to have the same things. All right, and then I subtract these terms, and I get 4x plus 7. All right, so here's what I know so far. I know that the integral of 3x cubed plus 25x squared plus 66x plus 25 over x squared plus 8x plus 18 dx equals the integral of, all right, so I take my polynomial part, 3x plus 1, and then plus my remainder, right? So this really, to finish the division, I should put the remainder, plus 4x plus 7 over x squared plus 8x plus 18, right? So here's my quotient with remainder from my long division. And so that's what is replacing this original rational expression here. 3x plus 1 plus 4x plus 7 over x squared plus 8x plus 18 dx. So right now I can pretty much continue from there. But just to show you where we are in the process, we've done the polynomial division. The polynomial terms, we're going to use the power rule. The proper remainder, we're next going to look at to see if the numerator is a multiple of q prime. In other words, the next thing to ask about the remainder is, could I use u substitution on this part? Wouldn't that be nice? All right, so here's what we mean by using power rule on these parts. So we can go ahead and do this part of the integral, 3x squared over 2 plus x, and then say, and now I've got to integrate this part. So we can do parts of the integral at a time as long as they're separated by plus or minus signs. So this is just doing the polynomial part. Okay, so now I'm going to look at the potential for using u and du. So if I use u equals x squared plus 8x plus 18, then what would the du be? The du would be 2x plus 8. I clearly do not have a chance to match 2x plus 8 with my 4x plus 7 up there. So that's not going to work. All right, so the answer to this question is no. So I'm going to go down. Oh, by the way, is the degree of q equal to 1? In other words, do I have a linear in the bottom? I do not. I have a quadratic in the bottom. All right, so now, does q factor? All right, that's a good question. Can I factor x squared plus 8x plus 18? Try it. No. All right, so where am I going to write that? I'm going to write that here, I guess. X squared plus 8x plus 18 does not factor. Non-factorable. Trying to think of how I can squeeze that in there. Non-factorable. All right, so then what do I do? All right, q factors, no. All right, let's skip down here and go, what is the degree of q? Is the degree of q equal to 2 or is the degree of q greater than 2? I hope that degree of q is not greater than 2, because I don't know how to do that. Maybe we'll, look it up or something, but we go crazy. That's what it says. You go crazy if q is greater than 2. If q is equal to 2, well, is it? Yeah, it is. That's our denominator. It's degree 2. Degree of the denominator is 2. Okay. So what's the degree of p? All right, what's the degree of p? Here's our numerator. Degree is 1, right? Degree is 1. All right, so the degree is 1. Linear numerator. All right, separated into kq prime over q plus constant over q. This is what I call in some of the worksheets forcing q prime. And that's what we're going to do next, is we're going to force q prime. So that's what we're going to do on this. But I'm going to keep this video shorter because the upload time is getting pretty nasty. So, but I'm just going to put what we're going to say here is force q prime is going to be what we're going to do next on this part of the integral.